Alright, so let's say we have this polynomial here, and this is a generalized polynomial, and we want to factor it. So how are we going to find the factors of this polynomial? So in this episode, I'll be showing you some cool tricks on how to find the roots of any polynomial, and hopefully these tricks will make it easier for you to factor a polynomial. So the first trick that I'm going to show you is the rational root theorem. This theorem is a famous theorem. It states that if you have a root p over q that's rational, so it has to be in the form p over q, where p and q are integers, then p must be a factor of a0 and q must be a factor of an. Now this is useful because you can use it to narrow down the amount of options that you have. And if you're only looking for rational solutions, so if you're looking for integer solutions, if you're looking for solutions that are integers, all it has to be is that integer, let's say it's p that you're trying to find. If you're trying to find an integer root of a polynomial, then it's just a factor. It just has to be a factor of the constant term, which is pretty nice. And another theorem that's true is, say we have a factor that is a plus bi. So it's a complex number, b where I is imaginary. Then another factor of the polynomial has to be a minus bi. So if you see a complex number as a factor of this, you know that immediately that another factor has to be the conjugate, which is a minus bi. So it's the opposite. And similarly, this also works for square roots. So let's say we remove the I and we replace it with the square root. So square root, let's say, of c. Then the other root would also be that same thing, but instead this is changed to a minus. So again, this is a neat trick because you can use, once you found one complex root or one square root, then you'll know that the next one is just the opposite or conjugate. And lastly, we'll be talking about Vietas formulas. Vietas formulas is very famous for quadratics, but they can actually be generalized to any polynomial. And the thing is, the sum of the roots of a polynomial like this is just so the sum of the roots, let's say the roots are r1, r2 plus r3 ... all the way over to Rn. So we have n roots. The sum of these roots is equal to -1 to the nth power, to the n minus 1 power, times, it's equal to the n minus 1 times a n minus 1 all over a n. So that's kind of complicated, but when you think about it, if a of n is 1, then this is simplified. And also finding this is really simple, so it doesn't really matter. And then you also know that the product of the roots is r1, r2 ... times Rn is equal to -1 to the nth power times a over 0 over a over n. So right here we have two formulas in Vietas, but also you can find other formulas for r1, r2, r3, all the way up to Rn, but I'll be discussing that in a later video because that will take too much time to explain since I've already explained some other stuff. So I'll be elaborating more on generalized Vietas formulas in another video. But anyways, thanks for watching. I hope you enjoyed, and remember to like and subscribe.